Thanks for coming. My name is Dabian, and we are Team Kryha. And today we're going to take you on a journey of our vision of the future. So here we go. The world we live in has many problems that require all of us to come together in order to solve them. The United Nations has set 17 sustainable development goals that have to be met by 2030. Recent reports indicate that these targets aren't going to be met with the progress that we're going through. The problem is that the problems that we are facing are problems of the commons, problems that are ownerless. So in order to solve these problems, we need an ownerless solution, a solution that can benefit the commons. So our vision is, or our answer to these problems are autonomous machines. Autonomous machines are able to carry out missions far more precise than us humans and are able to communicate and collaborate far more efficient than we do. In order to solve these problems, we need to rely on machines. And these machines need to execute missions based on humanity's needs. So missions such as providing mobility for all of us. These missions can be carried out, for example, by autonomous vehicles. Or a more complex case is Fukushima, where we can deploy a swarm of autonomous drones in order to do disaster relief. And maybe even in the future, terraform the Sahara deserts. So, our solution is highly inspired by nature. Nature is the most efficient and successful system that we all know. It encompasses a lot of the lessons learned in nature. For example, on the software optimization part, we looked at single-cell organisms, which are not limited like us mammals for sharing DNA on a vertical level, so by creating an offspring, but are able to share DNA on a horizontal level. For this, we apply federated learning. Federated learning allows machines to share learnings and mistakes across the network immediately. This ensures that whenever the learnings are immediately implemented and the mistakes are never repeated. For the hardware component, we looked at evolutionary theory. And what we did was basically have these machines, the most unfit machines, die out and create room for more optimized generation. So what we built here was based on terraforming Mars, which seems pretty far, but it's the most harshest conditions that we can think of, and where our infrastructure would be able to provide a solution. So Dan will walk you through the demo that we built.
What we built is infrastructure for the commons. We took available protocols for everybody and we just combined them. We did not create a new protocol that is out of thin air. This is industry specs and nothing is proprietary or weird about it. We actually enable everybody to run decentralized computation, which has never been done properly. I mean, there are projects that are working on that, and this is like an according to specification version. What you see here is basically an entire decentralized system which has drones requesting compute resources from our agents or from whatever. And all of these agents at the same time consume the same amount of population. Basically what happens is that what you've seen here today, each team has had probably 1, 2, or 3 applications that we built. We built 60,000 applications. All of them create our applications for us to test how far can this infrastructure actually help us and how far can we go. And this is what this is. All of these are agents that have their own Ethereum accounts, that have their own balances, and once every thousand blocks, we determine that, okay, the only top 20% of these agents which are the most fit for the functions that we do, in case of Mars, are actually the most fit ones to convert, for example, ice into water, soil into like usable ground. And in this case, only the top 20% get to father a child. And this is what you see here. We have a built-in ancestry tree in a blockchain because it makes a lot of sense for saving the DNA of the parents and to see where the offspring goes. So this is a part of the tree, and this is actually the DNA of each of them. This is a part of each of them that is going alive, and they get triggered to start again and again on Mars whenever there's a new child. Then, this is the actual cluster that it's running on, and this is not fake data. This is running live. We are consuming 72 CPU cores at the moment. That's why you're having this low. But at the memory, we're at around 100 gigabytes using it right now. And the amount of pods that we've done in the past 4 hours is 20,000, but since we've deployed this, is actually above 67,000 units. So it's basically an ongoing and living system. Then this is what our infrastructure supports, and this is what we wanted to do. Is there any specific thing that I've missed?
No, I think that's
I mean, yeah.
What did you hack? Because this sounds as if everything is decentralized.
So what we did is we hacked Kubernetes and Ethereum together. And we built basically an extended API on top of Kubernetes so that it is also not, your application is not only cluster aware, it is also blockchain aware. So this enables this entire construct of decentralized orchestration. And this is what we've noticed, that other teams eventually are going to need to use. We've spoken to SingularityNet in specific because we really believe in the SingularityNet platform, and eventually that will also have to be hosted on decentralized infrastructure. And right now there's not a lot of candidates. And we really want to research and push this forward because nobody has done this properly, so we're really curious, why not? Let's just see, let's find out. Because the only way we find out about the unknown, if it works or if it doesn't work, is if we try. We have to try, no matter what we do. So this is it. We're creating the infrastructure for most of these teams eventually to support it. So right now, everybody's going to run their application layer on blockchain or like the business logic, but the compute resources will probably be rented from Google, Microsoft, AWS. We're trying to decentralize that, and we're enabling communities to also power these clusters. The Dutch cluster.
What are your next steps? What are your milestones? What is your incubation plan? What are you thinking about?
The first part is to build the core. This is a proof of concept of the core, but it is not stable for production use. It would work today to host all the applications, but if we're going forward for infrastructure, we also need to validate whether the Ethereum or Tendermint is a good candidate. We don't know at the moment, we have to check. So after that, we have to run clusters, and we have to talk to VMware, we have to talk to Google, we have to talk to the Oasis and all of the blockchain companies to see how can we mix this technology together best? Because at Kryha, at least, what we believe is in the mix of blockchain and cloud technology to help decentralize compute. So that's the next step. Creating the thing and then testing it.
If I see this and I'm enthusiastic and I want to help, what can I do?
Reach out at Kryha and just tell us what you can do. And we will definitely give you something to research or to do work with. Last year, everybody reached out. We actually wrote a paper. We didn't do a product. Greg's was a research paper that was published 2 days ago with MIT. That was it. Everybody wanted to see something about it, but nobody wanted to build a token, nobody wanted to build a protocol, we just wanted to know, how does it work and does it actually make sense? It was cute.
basically it's something that we have to open up to everyone. So we need community support in order to get this off the ground.
Yeah. And this is infrastructure. So the most important part is also to have a community work on the security of it. So for example, I don't think there is any other way at the moment without Gitcoin to create the bounties and the funding platform for all of the bugs that we might encounter, because this is critical infrastructure at the end.
This is the critical infrastructure of the future, the distributed critical infrastructure of the future. That you're now operating live on 20,000 applications.
I am really surprised. I did not expect it to work, to still continue working.
How would it affect Mars? So this is of course, how would it work? What would happen?
Basically, with the learnings that we do on Earth by, for example, in the future terraforming the Sahara Desert, we can take these learnings and then eventually terraform other planets in order for us to colonize it. So that's why we chose Mars.
So this is the hardest form of infrastructure you could imagine. You will start on Earth and learn a lot.
Yeah.
Wow.
Fix
The most
Earth.
difficult proof of concept that we could have come up with.
Basically fix Earth first and then take those learnings to other planets.
Wow. What makes you so passionate about this?
Basically, we want the future we see as a future operated by machines, which gives us the flexibility to basically do whatever we want and stay safe and basically enjoy life to the fullest.
Wow.
And also we love bleeding edge tech.
Okay. Somebody else questions?
How do I see this operating from afar? How do I know that this is working and terraforming Earth?
So let's say terraforming Earth is, but let's bring it a bit closer, right? So let's say that if you get the new decentralized Uber, and you open up your phone and you request a car and it appears there, it's working. Because this is decentralized infrastructure for machines.
So you also work with an ownerless Uber.
Yeah.
Maybe. Yeah, ownerless, exactly. Sorry, ownerless, I meant that, yeah. It could work with owners as well, sometimes, I think. Should be.
It is agnostic, so it will work.
Yeah, it does not discriminate who you are.